Okay, so the next presenter will be myself, Singh, on my research project that I did during my final year of studies at the University of Ghana. This research
the two species under observation are the blue-violet boundary crab, which is about 110 millimeters by 102 millimeters, and inhabits muddy and sandy aquatic and terrestrial habitats. They use their chill heads to catch and tear their food and mate during July hours. The bluish yellow with pinkish red mangrove crab measures about 4.1 centimeters by 5.8 centimeters. It inhabits mudflats associated with mangroves where the adults feed on mangrove litter and ingests sediments while juveniles feed on polychaete worms and microorganisms. The aim of this research was to determine the socioeconomic status of crab captures in Region 1 and the presence of various dinosaurs and crab species,
the boundary and the mangrove crabs from mined and unmined areas in the region. These were my objectives. Part of this research was conducted in the Mora Passage, which is the largest and most intact mangrove ecosystem located in Region 1 that expands to around 50,000 hectares, of which 14,000 are mangrove forests. It contains 4 villages, namely Smith Creek, Aruka, Mount Marijuana, and Imbatero, which is where the crab species were harvested from. It is the most populated village in the area, containing wild and Venezuelan migrants that depend on the diverse natural resources for food and income. On the other hand, Port Kaituma is a more populated and biodiversity poor area in Region 1 that is inhabited mostly by Guyana's indigenous people, Venezuelan migrants, and others. It is mostly affected by gold mining that contributes towards heavy metal pollution in the area. To determine the sampling sites and socioeconomic status of crab catchers, 430 adults from Imbatero, Smith Creek, Marijuana, Aruka, Mount, and Port Kaituma were interviewed using structured open and closed questions through in-person interviews and over-the-telephone interviews. During May 2022, 5 adult boundary crabs were harvested from farmlands in Imbatero along the Kaituma River by directly inserting the crab catcher's arm into the gallery. This is called the bracciamento method. 5 mangrove crabs were harvested from the mangrove forest found along the Imbatero Creek and Kaituma River by using a cutlass to dig around the crab holes, stuffing the holes with leaves and mud to suffocate the crabs and force them to resurface after some time, and then pulling the crabs out with your bare hands. The crabs were then tagged and stored in quakes. The samples were washed, measured, and weighed and dissected to obtain 20 grams of muscles from their legs, abdomen, and cephalothorax, which were sent to Gaisuku's lab. To digest the samples for cadmium, copper, and lead analysis, the samples were oven-dried, after which 1 gram of each sample was transferred to a flask containing concentrated nitric acid. The samples were digested on a hot plate in a fume hood, allowed to cool, and transferred to a 100 ml volumetric flask using a filter paper. The filter was diluted to the 100 ml mark with distilled water before shaken vigorously and left to stand for 1 hour. To digest the crab samples for the mercury analysis, the samples were homogenized in a food processor and dried in the oven. 0.5 of each grams of each sample was placed in a digesting vessel of nitric acid and left open in a fume hood for at least 30 minutes, after which the contents were digested. After cooling, the digested samples were transferred to a 100 ml volumetric flask to which potassium manganate solution was added. The vessel was left for at least 2 hours. Hydroxylene with chloride solution was slowly added, and deionized H2O was added until the sample reached the 100 ml mark. To analyze the digested scrap samples for the presence of cadmium, copper, and lead, flame atomic absorption spectrophotometry was used, and for the mercury, cold vapor atomic absorption spectrophotometry was used. Quantitative data was analyzed using descriptive statistics on peer 2 samples t-test, 1 sample t-test, and simple linear regression t-test. Qualitative data was analyzed into differences and similarities. The socioeconomic status is the social standing or class of an individual or group measured by their education, income, and occupation. The majority of the interviewees were 41 to 45 years old crab catchers from Imbatiro, who only attended up to primary school and had 7 members in their household. The crab catchers from the Braymore Passage depend on the Bunbury and mangrove crab species for food and to sell at the Comaka market for $1,000 to $1,200 per quig. They harvest more than 15 crabs per day for 2 or more days a week all year round to sustain themselves and their families. However, due to the many factors such as overharvesting, climate change, and alternative livelihoods, there was a decrease in crab catching over the last year. Finally, and importantly, due to the low education levels in the Braymore Passage, the majority of present crab catchers are unaware of the impacts of gold mining on crab species. Now for the heavy metal analyses. A comparison between the heavy metal concentrations of the Bunbury and mangrove crabs demonstrated that the Bunbury crabs had the most lead and copper concentrations, and the mangrove crabs had the most mercury concentrations. Cadmium concentrations were below the metal detection limit, and there were no differences between the lead, copper, and mercury concentrations of the Bunbury and mangrove crab species from Imbatiro. Excuse me. A comparison between the heavy metal concentrations of Imbatiro and Kaituma River demonstrated that the Kaituma River had the highest lead, copper, and mercury concentrations. There was a difference between the lead and mercury concentrations of Bunbury crabs and mercury concentrations of the mangrove crabs between the 2 areas. A comparison between the heavy metal concentrations and the Food and Agriculture Organization limits demonstrated that all samples had lead concentrations above the limits. The Bunbury crabs had the copper concentrations above the limits, while the mangrove crabs had the copper concentrations below the limits. The Bunbury and mangrove crab samples from Imbatiro were below the mercury limits, and the Bunbury and mangrove crab samples from the Kaituma River had the mercury concentrations above the limits. These results prove that the mangrove crabs from Imbatiro are the safest for consumption. Finally, there is no linear relationships between the weights of the crabs and their heavy metal contents and weights of the crabs and their heavy metal contents, and the lengths of the crabs and their heavy metal contents. Thank you for listening to my presentation. These were the limitations, the recommendations. I have watched your thank you. And for the students that are in the audience, these are some of the recommendations I have for future work. I would like to say a special thank you to all of the persons that contributed towards my research being successful.